I've told somebody in the month, I had the unusual opportunity to both do the parks first, be part of, with my friend help write the book and do the work. First archaeological survey of the park and organized the archaeological database that you're seeing there, you've seen in some of the photographs that we've shown, and also develop a research design which would help. It intended to help Park Service go forward in how to manage their archaeological record and learn more from it, since it was all brand new. And then I had the very unexpected, in some ways tragic, opportunity to become the park's first and second archaeologist and be able to implement that same strategy that I developed. So what I'm going to talk about is go through the primary research design elements that occurred in that first book that I talked about here. That would be this one right here. I've got my pointer showing, and work with that. So what I'm going to do is go down to some of the key points that occurred in that book and talk first of all what kind of sites make up the mountain's archaeological record. They're not all the same, so when you're interpreting that to people that visit the park or walking across the park yourself, and you see an archaeological site, you have some notion that they're not all the same. And this is what we're going to try to do. So there are archaeological site types that were proposed in part by that book, but have held up over the course of time, over 16 years as archaeologists working in the park, that seem to fall into different categories that indicate different uses of different landscapes, somewhat. There are various kinds that are represented here first, and keyed them by color. The residential places where people stayed a length of time on the mountain. What we have is basically two kinds. Basically, there's larger ones with lots of stuff of varied kinds, cutting tools, piercing tools, grinding, hearths, that kind of stuff, which suggests residential use of the landscape for an extended period. By extended period, that's hard to tell. I'd suggest at least measured in weeks, possibly in a couple months. Rainier, at elevation anyway, is a wet, difficult place to live. Especially when your primary resource is probably salmon further downslope. But multi-week residential places. A second kind of more limited places were task acquisition spots, shorter term camping kind of places, where people would move out of a residential base camp into a camping place and back. And I'll show you some examples. Then we have locations, which are spots that were used to acquire a resource and take it somewhere else to spend the time, but didn't spend the night. As you can tell from the archaeological record, a very limited amount of time, maybe a day or two. The butchering locations, tool stone procurement, meaning tool stone to make those stone points we're talking about, is hard to come by, and it breaks. Stone tools are sharp. They work really well, but they break all the time. Because if they didn't break all the time, we wouldn't get all the junk that we can see and find an archaeological site. So it's really handy. But tool stone procurement spots are on Mount Rainier, but not very good ones, but they're here too, and elsewhere. Game observation spots, and then specialized stacked rock and talus feature spots. The newly added are something I didn't ever consider early on, but came because of became a major concern, mainly from more recent excavations in 2014 and 15 at Ohanapikosh, which are travel stops on the route getting up here, most likely, or use of hot springs, which have a dedicated focused use of their own, as Ohanapikosh, which I'll talk briefly about, demonstrates. So let's run through some of those. Yes?
Very quickly, what is a stacked rock and talus feature
I'll come to
location?
one and I'll show you. This is what the rock says. They're sort of enigmatic stacks of rock that's clearly not of natural causation. Sometimes they're circular, sometimes they're linear. Very common around Mount Adams and Mount Hood. Not so common in Mount Rainier, but we have at least one or two. So, and I got a photograph. So, multi-task mixed group long-term residential base camps. The primary example I like to use is a Buck Lake that I introduced earlier. So on this side of the mountain, on the north, up here on the extreme northeastern corner, accessible over Elk Trail up Buck Creek. And from the, I don't remember the Forest Service roads up in here, but there's no travel in there by no tourist visitation. There are very little anyway, because you have to be cross country. It's a cirque lake that's no natural outfall. It's being cored in the picture that you see here. I keep forgetting you guys aren't seeing this thing. Can you now? Right there, being cored, with the site itself being primary up in this area right in here. Very deep. very deeply stratified site as well. Shorter-term limited task hunting camps are things like rock shelters that provided shelter without having to be built up every year for shelter from the inclement weather. Anybody using Mount Rainier National Park for an extended period of time, you know you can cover any kind of weather, almost any time of year. 1995, for example, when we did our survey, we got an up frying pan, when we documented this site. I keep forgetting, not seeing it. The Frying Pan Rock Shelter site. We had 2 days of continuous snow in early August, you know, and I was post-holing deep enough when we went over Panhandle.
Wow.
Yeah. So that was my introduction, and I was wearing blue jeans too, which was, I didn't do that twice. Butchering locations, probably the classic best example of the parks is Frozen Lake. So those arrows, you see here, the yellow lines are pointing to actual locations. If you're working up there and you're going to take your time to go off trail, I don't know how much is permitted, but employees do, don't take anything, but you will see chipstone material, which is shows like this, and foam materials. Most foam materials have been collected and are in a curation facility at Mount Rainier National Park that are visible, but there's quite a lot of material up there. And people walk through that every day. You can see where the trail, here's the, I can't forget it. That's the picnic park where people stop and rest all the time before they hike up Mount Fremont Trail. Go right through it. It's a windy, sunny spot. Not very good to live in, but a very good place to dry game. And the tools you see are very, very classic cutting edges on those tools. Oh, I'm really hindered by not having a pointer. Lithic procurement places. This is in Spray Park on the northwestern side of the park. There's a tool stone source just behind Mount Pleasant, which is right here on the other side, not that far from here. This is a spot where people sat and reduced the stone material into usable parts to make items out of. And you can see those in these illustrations that show here as well. It's just debris, debitage, chipstone flakes all over the ground there. No sign of any harms or anything people would stay. Another site type, game observation locations. This is also in Spray Park, overlooking Mist Park to the immediate north. And they tend to be characterized by a relative very low distribution of materials, but very, very clearly stone tool debris, probably from reworking tools while they were sitting on looking for game, but at very low density. But materials are easily recognized as different. You can see it down here by the glassiness of them and by the characteristic flaking patterns on them. So game observation locations. Specialized stacked rock talus feature locations. This is sort of difficult to see in two dimensions, but what we have here is a ring of rock and a ring of rock on each side, and they're located on a very small talus feature that shows also in Spray Park, right about where the arrow is pointing. The uses have never been satisfactorily documented or figured out. The thing that makes the most sense to me is why large element rock was removed is perhaps in temporary storage for hunted materials. When it was a hot mosquito-infested day when I recorded that site, and I noticed when I was standing right down in the lower part of it right here, my legs were cold. So, what about something? You have to leave the area if you can keep meat packs cold for a period of time. Put big rock over the top of it, and hopefully nothing bigger than a rodent will get into it. That's just a guess. I don't know. They also, people offer that they look like they're hunting blinds, possibly are in some cases. Not this one, but it could have been. Hunting blinds, that kind of functions as well. They're very common in mountainous locations in the Pacific Northwest, except Mount Rainier. I don't know why. They're common in the Cascades elsewhere, though. And they're present here, but not very many. And finally, short-term travel stops. So this is like the case site of is the recent excavations in Ohanapecosh. In 1914, in doing archaeological surveys associated with the new water systems going on, sewer system there, we did a surface survey and found nothing. And in fact, all the years that Ohanapecosh has been a campground and easily visible, we've never found a bona fide archaeological site in that area until 2014, because associated with the the water line, sewer line replacements, we did subsurface testing with the in-curved handled post hole digger. It allows you to go underground in uniform circles up to about a meter to most a meter and a half, and sample the sediments that come out, screen them, sample them in uniform controlled volume amounts, constant volume sampling along that line. And we found 9 archaeological sites. 9, a lot. All underground, about a half a meter. So that's weird. But that's where they were, and but then the park, bless its heart, funded that for the next year, for an extensive survey the next year, and we increased the number further, and there's been further yet. So I don't know what the final number is now, but over a dozen archaeological places, mostly all small, with evidence of very short-term stay, not very large in size, but with clear features. In this case, a hearth feature with charcoal on the bottom, bracken fern root is one of the elements in it. Which is often regarded by indigenous folks as travel food, common, edible, as well as other things, and a few tools, and off they went.
What was it dated?
I'll come back to it at the end, but the oldest date we got of was 7,775 years ago. The oldest date. Most of them are dated up to, not more recent than, about 1,000 to 1,500 for dating. So there's been some sediment replacement event. Basically, they washed away the archaeological record and redeposited. And that's the only thing that really explains it.
So while they're redoing Prakash this year, are they
I'll have to talk to Ben, MDS. He doesn't consult me, stinker.
They are, actually. I met the Caesarals
Yeah.
On Tuesday, and they said,
Good.
yeah, they're at Ohana.
Oh, cool. That's a
Yeah,
wonderful.
during
It's
everything that's going on right now.
good.
I think it'd be a good time to find.
Yeah, it's more. Of course, it is. It is.
Can I?
So I was the archaeologist to 2016, and that was still in process. And then Ben was working with me, took over after that. Still is. Ben Diaz. You'll picture him later. So, okay, let's just, one of the things that was remarkable I mentioned earlier was upper elevation habitats. Not all use of the landscape is upper elevation, obviously. Ohana Prakash is, for example. But it does contain sites that appear to be related to travel up to higher elevation locations. So why did we go there? Why is the archaeological site so abundant in that setting? That's the question of the day. Assuming it wasn't all just observation error. We've been in the park so long, and there have been so many sources of information from the park and others that there's a clear, distinctive, differential use of that place.
Because things are growing later and animals go high and stuff.
That's partly it. Yeah, that is the lateness is a factor. So let's just go into it. The key to understanding the use of the upper is key to principles of ecological succession, basically. And that is, in the Pacific Northwest naturally succeeds, if not modified in some way, to a landscape dominated by trees. This is a simple part of it. They're high in cellulose, their basic biotic potential of a dense forest is low, because so much of the energy is bound up in cellulose and growing matter. The most productive places for a variety of resources are in places where something interrupts that natural pattern towards revegetation, either by late lingering snowfall, in places like Sunrise, where it melts out so late that trees are retarded, burns, anything that would retard tree population tends to be more productive places. So in the maritime Pacific Northwest, plant communities tend to succeed at densely forested, ungulate poor, late seral stage environments, and less maintained at more open, resource-rich early to mid-seral stage. So resources, especially ungulate resources, and a variety of plant and animals affiliated with that environment thrive best when the forest pattern is broken by some event. It can be a climate-related event, it can be a desiccation, it can be fire. The ethnographic account is rife with, and including Mount Rainier, early reports by Grenville Allen talks about Indian people leaving the park and lighting fire to the forest, as is their custom, annually. That custom is good for them. And he says it makes the place better. You can see farther. There's more graze for horses. More graze for horses, more graze for elk, more graze for deer. Also glacier lily, and a suite of plants and animals that are of differential value to human beings. In essence, That's what they are. Dense pine forest, poor ungulated habitat in others, open patchy meadows, better, by whatever means they're created. And the Mount Rainier, because of its extensive height, and breadth, has more territory, landmass in subalpine context and alpine context than any other mountain in the United States. Well, I don't know about Denali, in the continental United States, short of Alaska, that is. So foragers were attracted to upper elevation subalpine landscapes because they were good for them, good places to be. Tended to be resource rich during that time that they were available. So that's the only reason I can come up with for it, compared relative to the surrounding lowland forest. There's also some resources that are available in high elevation settings that aren't found elsewhere, primarily mountain goats. Mountain goats are a really important resource for pre-contact people as well, because like cedar, the mountain goat wool has qualities that linger, that last. The value isn't measured out just by calories consumed, but the value in warm clothing, water repellent clothing, is amortized over maybe the 10-year period or more after they're collected. So mountain goats are important. It might be the primary draw. Some people argue that. So basically, you seek out those places because their archaeological record just is consistent with an argument based on differential use of those environments because they're resource rich. They're not the only place, because lowland environments have important resources too, but they're more difficult to see and they leave less of an archaeological signature. Things like Pipsissewa, for example, are important, but they were collected lower elevation. So some of the other questions are, how long have people used the mountain? It was one of the archaeology has several saving graces, I think, that other sciences don't. One is you can deal with time. You can deal with human change through time. It's a primary reason for being, other than the fascinating artifacts. But so, how long have people used the mountain, and has that use been continuous through time? Let's start at the beginning. When human beings, and anatomically modern humans, most plausibly evolved in Central Eastern Africa. And it came out of Africa. Modern genetic data is changing the dates. They were talking about anatomically modern human beings, but for the moment, let's call it 100,000 years ago. That's all the time we've had to take this planet and break it down, practically. About 100,000 years. Some say 60, but we'll say I'll call it 100. That's when human dispersal began to occur worldwide. And the pattern, human beings we know that human beings colonized northern Siberia as late as 35,000 years ago. By 35,000 years, there were human beings in Siberia. Between 35 and 23,000 years ago, that part of the world was under locationally isolating glacial maximum. So that was the period of the last glacial maximum. It was peaked at about 23,000 years ago. Much of the northern environment, northern hemisphere, both east and west, was blocked in massive ice, with open periods of tundra, punctured with tundra ice. But Bering Strait, the Bering Strait was arguably totally blocked from Alaska into North America by that glacial ice mass up about here. If you see the pointer working, right in there. So you have a situation where you have open areas of Siberian tundra supported large game animals like mammoth, mastodon, muskox, direwolf. Lots of pretty substantial resource base for people to subsist on. And people did occupy that part of the area, and extreme western, Alaska, eastern Siberia, western Alaska, as early as 23,000 years ago. But there's no evidence of human populations penetrate any deeper into the new world, into the Western Hemisphere, than that at that time. The glacial ice mass, the last glacial maximum, began to waste away about 18,000 years ago. By 16 and 15,000 years ago, there was a seam that appeared. This is old news. If you studied this, if you studied this kind of thing in the 60s, you'd have gotten the same point. A seam on the eastern side of the Rockies, where the two major glacial ice masses met and formed a sort of a seam. the Montane ice mass, Cordilleran ice sheet on the western side, you can picture, I can picture it, I can't use the western side, the continental ice sheet on the eastern side, separated at their shallowest point. It's the arid area on the east side of the Rockies that's still there today. It's not, it doesn't rain as much, it doesn't snow as much in the rain shadow of the Rockies, and that was the weakest point. That we know now from modern studies that was an open seam that developed there about just over 15,000 years ago. Another alternative route, where people have argued that people entered the New World by one of two alternate routes, one through the ice-free corridor in the eastern side of the Rockies, the other over a water route. It's been staunchly argued. This is very current in the field right now. I can tell you the breaking news is the water route didn't happen. There's no it may come up to this, but it's been presented as a model. It made sense as a model. They've never been able to find a bona fide archaeological site linked to it yet. The earliest archaeological sites are all in central Oregon, as far as Central Oregon, but nothing between Central Oregon and the coast. So about 15,000 years ago, you have earliest migration of population into the New World. There are a few outliers to that. If you're on the news, White Sands National Monument, for example, has human footprints in direct association with Pleistocene megafauna like mammoth and others like that. Pretty impressive. The mammoth are still there at 15,000 years ago. So that's good, but their dating's not. And that's the biggest news from that. They're arguing 21,000 years ago. It's too early to be true. And it's alkaline soils there. They have carbonate contamination. That's the basic argument of their radiocarbon samples. Ongoing argument in the field. 15,000 years ago for sure. That's the base. So you've got people in this area probably no earlier than 15,000 years. So Mount Rainier, the use of Mount Rainier, as we're interested in, cannot precede that. So how do we get it? When it did develop? We now have 3 sites that have been tested on Mount Rainier itself to document the earliest use of the mountain. And they're consistent with one other site at North Cascades in mountain environment, and that might be it. And the primary linchpin of this is Buck Lake, which underwent excavation between 2005 and 2009. This is one of the big drivers of mine when I hear it first is how long did people get here? Because at the time, there's one body thought that people didn't use the mountain at all. That's not true, obviously. The other was, well, they didn't use the mountain until, and I argued, and they probably didn't use it until about 35,000 years ago, coincident with the development of villages around there, because people wouldn't make the logistically difficult trip up to this place earlier than needed to get resources. So Buck Lake was the first site that rejected my own model in that earlier report. I punched through and found material remains earlier than 35,000 years ago. The question was how early. Happily, Buck Lake has a long get a key stratigraphic record that goes down at least to Mount Rainier R, dated at almost 10,000 years old. You get where remember the 10,000 years in the first slide, so you can guess where the oldest record's going to end, and it goes older than that. If you look at the difference in the sediments, even the sediments here, you have charcoal staining abundant throughout to about right there, and then it's clean. So Buck Lake was a project we conducted for 5 years, and we still do archaeology in the park, in a 3-stage mechanism. First, survey the surface survey, visually survey the surface, identifying 5 archaeological cluster surface remains. Here's Buck Lake, surface remains, and then go in with these incurved post hole diggers so you can get subsurface remains without damaging the sediments too much by digging meter deep, 1.5 deep holes in constant volumes, excavate them, screen for the results, as you can see, and then find if you get chipstone tools or not, if chipstone remains in them or not. Once you've identified that, you do big larger excavation units in step 3 to find out what you got in greater detail. The project conducted jointly with the Muckleshoot Indian tribe. They came out annually and assisted and lived with us up there doing the observation. And here's the present archaeologist of the park at a younger age, Ben Diaz, who's now the archaeologist for the park. And it's sitting there recording recording the constant volume sample results here. Once that's finished, then the final step is to get a better exposure by excavating the site very systematically in a manner that allows us to get the cultural material that's involved there, record it in place, photograph it, document it in very either 10 centimeter levels or individual volcanic layers, whichever is smallest. What this shows is that work in progress in October of one year or another. So just to give you sort of an example of what it comes down to, that surface, it's showing the surface of the bottom of an excavation unit that's still wet. I can show it. So the broader area up here, and the bottom of several hearth features that were arrayed on that surface. That surface dates to about between 4,000 and 3,500 years ago, and I'll show you why we know in a moment. And it had an absolute incredible density of material. I mean, that one layer we're talking about had over 14,000 pieces of chipstone that we individually picked out of the screens and collected. You know, there were nine individual. This was in what looks like a single 1x1, actually excavated out to a 2x6 meter unit. So nine hearth and pit features, gizzard stones from grouse stones, hugely high number, things that you find in archaeological sites routinely and are important item identifying because it shows and all the work I've done away from an archaeological site, I've never seen a gizzard stone from grouse or any other bird, like chicken-like bird that has those kind of things, other than in an archaeological site. You know, right near association of hearths, didn't fancy that. You know, very informative because it's obviously they're getting the birds right near the hearths there, and that's where they're eating them. And projectile points of other kind, other form tools. The importance of artifacts getting them in stratigraphy can be overstated because Mount Rainier is a special place in a lot of ways. One of it is because of its repeated volcanic history. If you're an archaeologist and you can find an archaeological record, you can deal with time, which is what I've already argued is one of the main reasons to exist in this field. To exist is we can look at things through time and meaningfully deal with questions like early use of a place. Do you change use patterns through time, across space, related to time? And so having the stratigraphic record separated out so neatly is really, really rare archaeologically. Yes?
So with that volcanic history, I'm sure I could Google this too, but since I have it here, how many times has the volcano erupted since in the last 15,000
Our
years?
volcano?
Anything that would affect like the area of Rainier?
Well, the primary volcanic events that affect Mount Rainier are Mount St. Helens and Mount Rainier, of course, itself. Mount St. Helens is an explosive mountain. I don't want to go too far in geology because I'm stepping out of my comfort range anyway. But this is my understanding. The gas pressures have built up at Mount St. Helens over the years. It's had a series of successive explosive events routinely during the Holocene, during the last 10,000. The Holocene, back to that first question, is usually regarded as 10,000 years old, but it really is the period of time since the wasting of the last glacial maximum. Terminal Pleistocene, very early Holocenes, from basically 10,000 to 15,000 years ago. So during the Holocene period, St. Helens, I can't give you an exact number. Let's say we've got St. Helens eruptions about 16 times. Mount Rainier is leakier. It had a massive summit collapse, the Osceola Lahar event, you're familiar with, at about 5,300 years ago. And it's had a series of some eruptions of Mount Rainier R, for example. It did have this sort of spatter eruptions, but they don't go very far because it's not tight rock. They aren't as explosive. The biggest event happened was the Osceola Lahar, in which the eastern northern quadrant of the mountain collapsed. It came down the White River. Most of it came down the White River. They have a splash event right over Sunrise Ridge. You can see. I don't have the slide documenting it, but we did see it, where a big wave of material came off that face of Mount Rainier, came down the northeastern face of Mount Rainier, came down to the White River Gorge, splashed up over the top, inundated Sunrise Ridge, determined by the presence of fine-grained sediments and boulders and all kinds of junk, unsorted. High energy event that lasted almost no time. just hit and done, and moved off. Then it had a series of other eruptions also, but the answer to your question is that I don't know exactly, but it's about 5 or so.
Logical sites really well.
Oh, yeah,
Those
right, well,
quickly.
it's right in your front, right on the screen right now. These, I wish it was a little brighter, my show was a little brighter, but these big layers, this is Mount St. Helens eruption from 40, these are the latest dates from 42,000 years ago. BEP means before present. It's awkward, but it's roughly 42,000 years ago. That was huge, a huge event, huge enough that the cultural material below it, you can see by the charcoal staining and by the presence of these artifacts like this one here, are separated chronologically from those above it. So right in here. This was the first site that broke my model when we were excavating the site. When we got down, I remember the day really well. We excavated down through this level. They came up with the first artifacts below it, below 40,000. And I said, first thing out of my mouth, that better be a dart point. There wasn't any bow and arrow yet. It had to be a dart point. And they were. Oh shit, that was great. What I thing about fun is really fun to be wrong if you can learn from it. So that was the
So are those ash accumulations?
Those are usually called ash. That kind of applies really fine grain, but some of them are very coarse. Mount St. Helens, this eruption of Mount St. Helens was so large, the Y eruption, it's everywhere. And it's always orangey in color, and it's coarse grain. It's like coarse sand, light bulk density. I think you walk up the trail to Mount Fremont, it's places where it's exposed. It's all over the place. Certainly you can in Paradise, when you walk the trails where you get it all the time. And so there were a series of eruption events here that don't really show very well. Also in here because it's dry, basically it's not really showing as well. But there are a series of eruptive events higher as well. But major ones like this, and Mazama O is a time marker all over the Pacific Northwest. Mount Mazama is Crater Lake. Crater Lake sediments are ashy or in texture, very fine grained, also huge. So these major events would have smothered vegetation on the landscape for a time, sort of like the more recent St. Helens event did, for a very short period of time. Then they revegetate. One thing that happens when they revegetate is they create an early seral stage all over again. And things like, you may recall, when after St. Helens eruption, the Forest Service began, a few years after, like 20, they began having problems with overpopulation of elk. They recreated the early seral stage environment, started up again, great elk habitat. They were hunting it out, or moving to other places. As it goes more towards foresting, then they recover. You also have, immediately on top of that Mount St. Helens Y event right in here, there's those 14,000 artifacts and the hearths and stuff like that. That suggests either an intense use period happening because you have all of a sudden a very early seral stage environment where it becomes very resource rich, richer than before, or population density increases, something like that, something. I'm off subject now, so are we okay? Stratified archaeological sites, especially stratified meaning layer cake kind of figure, allow you to learn a lot about the past if you can muster enough time and effort to research it. And Buck Lake was my favorite place on the planet. What really, the earliest use on the thing was the finding of the first article, human-made artifact, bona fide, no doubt about it, laying in a horizontal position on the surface that's covered by Mount Mazama tephra, was this biface of chalcedony. Material not found locally here at all. It's human work on both sides to provide a cutting edge, and it was right out of the wall in situ. There are other flakes with it as well, but that was a goosebump event. We got something down here around 8,000 years or more old.
So that was something brought in
Oh yeah,
from elsewhere.
yeah. So when you take that whole site and break it down stratigraphically and try to make it appear graphically in those events, you can correlate the archaeological material removed from the excavation level in which they occurred. And we did 16 levels. These are as they were excavated on the site. They extend them across. So we have Mount Rainier event 2,200 years ago. C. Then we have, these are the big events, not ignoring the smaller ones. Then we have St. Helens 42,000 years ago, Mount Mazama 76,000 years ago, and Mount Rainier R, another one, at 93,000 years, 97,000 years ago.
And you have this is debitage. It's a word from garbage. It's basically
Chipstone tool remains.
it gives you an idea of relative density. If you time there's that big event, and this layer right here. Oops. From the event. But debitage features are. I'll go through. The debitage is chipstone tool waste remains. Features are things like hearts, things that lose their integrity when you excavate them, but were present previously. Stacked rock features. Gastroliths or gizzard stones. I'm one of the few that I'd like to think. I was one of the first. I don't care what it was. I mean, who did the gastroliths tell you something about human use of the mountains too? So we collected them as well. There's the pattern, and then form tools numbers over there. These are the real numbers, field counts that we did in the field.
And they established earliest use of that landscape at that place for the first time in 2009. Ever done. It was quite a remarkable event for me and others. And I'm going to argue that this artifact that we saw came from that with this is 130 pieces of additional stepstone and that tool and one gastrolith. So now the debate is whether if you accept gizzard stones in high concentrations in a place, a fairly high number, in my experience, from a place that's a direct association with cultural material that sets the use of the park back to sediments that dated to 96,000 years ago. 9,600.
9,600.
Sorry. 9,600.
Yeah.
Yeah.
And there's the radiocarbon daters. You can't really read them, but there are the critical arguments right there. If you go from stratum 11 and you regard gizzard stones in an archaeological context as being indicative of human use necessarily, you push the age back, the mean date would be 96,000 years. 100 years.
600.
Don't let me say that, you know. Friends slap me. Stop doing that. If you accept only chipstone tools, the range, then we've got to push back to about more like 9, even. Still pretty old. Yeah, people have been here a long time. Yes?
So where would people go when there were major disruptions with the environment? Or can we just assume that those events
Well,
are happening in season?
they're not that broad. You know, this eruption of St. Helens, you know, Mount Rainier gets a bigger, mountain environments get a larger drop than others because they stand up so high. And they create wind patterns and drop patterns that allows the depositions to be heavier. There's no indication that people had to abandon the broader region. They certainly would abandon use of the mountain for a little bit. You know, but if St. Helens is the most recent eruption at St. Helens is the indicator, Mount Rainier after that big Mount St. Helens Y erupting event here shown by that one would have returned fairly quickly. Anyway, they would be displaced to the lowland environments. They'd just not be able to use that place for a few years and then they're back. Humans are really invasive species.
Yeah.
We know. So these things. Boy, it's not a place you can get the basic data by going to that report, the 2006 report that I mentioned earlier. I can give you. We'll get the link for it up there. It's not in the 1998 report because this was all found using their search design. It's not in there. We didn't know about it at that time. But by 2000, it's got a 2007 date. But that was a mistake. It was really written in 2009 when this was all fresh. So it talks about the time dates, and it's also alluded to briefly in the book that I've been promoting all day. Okay, so we are coming up to the sort of end of things. Take yourself back to, if you're an archaeologist in the park, Ben was here at the time too, it's pretty exciting to get this kind of site. It was the first time, and at the time there's only one other site in North Cascades that indicated that human beings used mountainous environments in the Northwest at 9,600 years ago. We were jazzed. So was that a one and out, done site? Or how do we use our limited, practically negligible budget and try to make an argument that we had mountain used more generally? So we came up with a pattern. Well, let's look at another, what we've already identified as a residential base camp setting, which we'd already done previously for Buck Lake, and test it on the other side of the mountain. And there was one on the opposite side, which is up Couch Creek Trail towards, what's up there? What's up the top? It's been way too long. Pardon? No, it's a Couch Trail, you go up,
Devil's
Towards
Green.
Indian Henry's?
yes.
And Indian Henry's.
Yes, up towards Indian Henry's. Exactly where you go. Just before the trail goes through a sharp increase up the face, there's another, at moderate high elevation, there's a creek there that had no name. So it's become Forgotten Creek. Buck Lake has no name either, by the way. I've called it Buck Lake, but it's on head of Buck Creek. Forgotten Creek site, as it shows on the little sub down here. So we got Buck Lake over here, Forgotten Creek over there. Let's see if we can get lucky, basically. Can we replicate the results in a similar environment with a similar type of site, hopefully with stratified deposits? We didn't know yet. We hadn't dug a hole yet. So the first year was simply to dig a set of constant volume test units across the site, and we came up with 6 pieces of obsidian below Mazama ash.
Wow.
I should have that picture here, but it'll be expert. So that was exciting again. So we got something. So they did one more year simply to replicate the results. We didn't invest as much time. Our basic job was to understand whether or not we had that 9,000 years. And there's the 1-by-1 excavation unit that I was standing in the previous year. There's Carl Fabiani, by the way. Give him a hard time for not coming in today, whoever I talked to about that.
Oh, that was me.
Yeah, you were featured. This was the excavation unit. You can see some of the similarities. We had on the other side of the mountain. Here's the St. Helens W, which is a more recent volcanic event that wasn't represented. All these volcanic severs aren't exactly the same on each side of the mountain because it depends on the wind patterns at the time they erupted. But the big ones did, like Mount St. Helens Y, Savannah, again 14,000 years ago, and then Mount Mazama O, and then the obsidian. It's very little obsidian toolstone in Mount Rainier National Park. After all our years excavating, we've got a grand total of maybe 20 pieces of obsidian, and most of them are right there. So the people probably coming from Oregon Obsidian Cliffs area on the east side, maybe, on the west side of it. So the radiocarbon dates confirm that more or less the age range. Didn't dig any further than that, and that was that. So a basic argument from here was, well, we've got comparably aged sites on both sides of the mountain. There's human beings all over the place, way earlier than I expected. Pretty cool. And quite unexpectedly, Ohanapekosh campground excavations. While I was still chief archaeologist for the park, in 2014 and 15, is still going on. The work is still going on today, apparently over in there. I don't have a lot of time to spend in that, but no archaeological properties had ever been documented in Ohanapekosh campground at that time, despite being essentially denuded environment for people by the end of the summer, as you know, and starts over again. So we've conducted a series of constant volume sampling units associated with the just off the side of where the excavation lines were set to go in the years that followed. They're putting in now, and check the remains for chipstone tools. And lo and behold, we got 9 sites that way. 9, a big number for this place, all underground, not showing on the surface area. And the park freed up funds then to do more extensive testing until 2016, and that's the results that I'm dealing with right here. We call it the comfort station unit because the biggest excavation unit was right next to the Loop C comfort station. There they are. We've got a lot of visitors that year. But in this case as well, we documented extensive use through time. Mostly these small, very, very uniform stops areas. They look like temporary camp, maybe overnight. I'm calling travel stops. Although I now have to consider focused use of just the hot springs too, because they're geologically old too. And they're writing up the report on it right now. I should be writing it right now, but it's in the works to figure all this out, and so it'll be forthcoming soon. But this is the excavation that while it was in progress, and at the lowest levels was being excavated by Lori Michael right here. You notice the stratigraphy isn't as clean. It's not as stacked as before. It's been in a forested environment, particularly in a lowland environment. We've got
dense forest, and lots of tree tip-ups, volcanic stratigraphy tends to get homogenized through time. But there are pockets that are not. You can see through time in that you got pretty good stratigraphy up here at the top, including a very, very thin layer of the when was it? 80, right?
Yeah.
Eruption, which did put a deposit down there. It can barely be seen. If you want to give a key to it, you can see it if you're really lucky. But giving you some sense of how big the other events are that you can see. But it's there, and all the recent eruptions are there, but they're very hard to find except in pockets below that. But in this pockets where she's excavating, in a place underneath what looked to be a pristine Mount Mazama, Crater Lake. 80, I forgot the date for it. Call it 8,200-year-old date. Anyway, it's the excavation date. We got an artifact that's consistent with that time period. Very, very, very small fragment. It's called a wind dust point that's characteristic of that early time period. Not necessarily, but characteristic of it. And radiocarbon dates that suggest 7,500 years. So we got 3 points on the scale. So basically, how long? The answer is a long time. I'm calling it 9,600 years, or 10,000 rounded up. Back to the first slide. So I'm going to have to go pretty quickly here and tie this up. This could be a course. If you read the article, Subsistence Settlement, the Archaeology of Mount Rainier and the North Cascades, the article, 2007, written, which you can key in, it will discuss what forager collectors are. But hunter-gatherer populations, like other populations on the planet, change their use through time to accommodate increasing population density on the landscape. The earliest use periods, those sites were used 9,000, 8,000, 7,000, 6,000 years ago, were used a system of the landscape in which full social groups, organized social groups, move around the landscape as a full group. Their residents and their use of time tend to be semi-sedentary but highly mobile. They move from area to area as use resources while available, then move to a new area seasonally or over longer periods of time, so long as the resources remain available. There's a tendency, however, at some point when population density gets high enough, there's too many people on the landscape trying to do the same thing at the same place at the same time. And that's where competition comes from. And that's where hostilities come from. And that's where pressure comes from. And there comes pressure then to become fixed in space, to develop settled communities in places where your resource base is more stable. In the Pacific Northwest, that traditionally means salmon. So you said you have a punctuated, almost just, if you were doing a NOVA report, it'd be like lights popping up. You have what has been mobile populations all of a sudden become fixed. And they become fixed in predictable places in the Pacific Northwest, that's salmon rivers. Relying primarily on that as a source of protein and such. But salmon can't be exploited in numbers and then walked away from. Nor can agriculture. It's functional equivalent of agriculture. It's really no difference in the way it affects populations. You've got to stay with it because you can't leave salmon. You've got to organize when it's collected. It takes a lot of labor to collect. It's got to be dried. It's got to be preserved. It's got to be kept cold if you can. So primarily your best seasons are fall seasons or late summer when it's conflicting with uses of the landscape elsewhere. So it tends to be then the whole system changes around to what's called a collector. Become called a collector, foragers, so become collectors, of which settled populations, special use groups, they return up and back. Instead of populations going around the landscape with minimal storage, minimal development of that, and all of a sudden become fixed with task groups going out, getting stuff and bringing it home. That's the model. So does the archaeological record show it? And that's tough to see. So this is the most sketchy. The models, there won't be a quiz on this. So this is much too complicated to try to go through, but a number of people in the Pacific Northwest, and I was one of those, developed models to explain changes as a model should have occurred if you're correct, based on certain assumptions about how people use the environment. All of which have recognized the distinction that happens all across the Northwest and between about 4,000 Now, about, they say 4,500 and 3,500 years ago, so when you get these fishing villages going, when foragers become collectors, how does the archaeological record, does it reflect that change? Can you see it in the archaeological record in a place like Mount Rainier, where people arguably never really settled down here, but can you see a difference between people using the mountain more intensively with tethered villages versus the way they did it earlier in time? If it can be seen in the archaeological record in this place, Mount Rainier's the place to look, because it got such good stratigraphy, separate samples. So, and those red lines that show in here and there, that's primarily collecting economies. And these are different models that predict slightly different times, but they're all about the same. And the answer is, did a fortune to collector shift take place recently? Well, we know that did. Then you can bring in the lowland archaeological record. Yes, there was a shift towards settlements at about 3,000 to 4,000, 4,500 years ago. Can we recognize a change in the archaeological record on Mount Rainier? It's still a maybe. I'd really love to get a chance to rewrite the research design document all over again, because now it's time to go through the record hard. But it looks like places like Berkeley Park Rock Shelter, which we know was used only during if you remember way back in the start, was used only around 1,000 to 2,000 years ago. Obviously, collector times. The only thing, there are some differences in it. Only arrowheads. And there's arguments made by the person who wrote a report on that. I don't have it with me right now. Pacific Lutheran University, though, that it does that the character of the remains are consistent with expectations developed by a person named Lou Binford, who developed this whole system a long time ago. So, arguably, are related to collector use of the landscape. And I'm flailing because I don't know. Really, that's why I'm not certain about it. The other indicator that might indicate that it took place is that a very punctuated increase in use of the site at Buck Lake at that same time period, and the sheer presence of a lot of archaeological sites on the modern ground surface. So there's a chance that this simply the use intensity of the mountain increased during time. That's all I can say really.
So the evidence at the other volcanoes compared to Rainier, is there a difference on behavior based on the elevation? Or is it more the stratifying of the...
I have a lot of experience on Mount Hood, less on Mount St. Helens. Mount Hood is a peaky volcano, peaky mountain, not broad one like Mount Rainier. Because of that, it has a very small representation of subalpine habitat compared to Mount Rainier. It also lacks the stratigraphic stratification that Mount Rainier has, because the sources from it didn't benefit from Mount St. Helens use eruptions. Right. So we have the archaeological record tends to be squeezed into a little bit of ground. So those are the caveats. I think that the use of mountain environments are useful for people for the same reasons, but a place like Mount Hood compared to Mount Rainier would have been less useful because it would not have the same resource patterns, simply by the shape of the mountain, and a little bit lower. So does that get the other way?
Well, I mean, that's part of it, but I was just thinking if some of the other volcanoes had more use, more evidence of use, if it was based on elevation and more ease to get to it rather than Rainier, just because of the elevation.
I cannot answer your question. I'm not sure. I can only really speak to Mount Rainier, and there is an indication that its use is. Well, here's a summary of what we think. I've got next two slides. I've only got 3 more left. Sort of summarize it. It's on your sheet too. What we think, we actually know. At some point, science has got to get to the point where we keep saying, well, maybe this, maybe that. So what do we know is near fact. As near as I can say for right now is we know, and that is. Start from the bottom, working up. As the first foragers moved south into North America, right at about 15,000 years ago, a little bit earlier, but not much.
The earliest known vegetated upland habitats in Mount Rainier, which you now know from an extensive sediment coring and some lake profiles that I didn't talk about today. We have vegetated habitats. Mount Rainier begins looking like the modern mountain about 12,000 years ago to 11. So I'm right in there. That means it became suitable for human use about 12,000 to 11,000 years ago at some level. People began use of Mount Rainier habitats about 10,000 years ago, 9,600 years ago or so. And these cascades generally start about that period of time. There's abrupt increase in, about 4,000 years ago, there's abrupt increase in mountain subsistence. Abrupt increase in the number of archaeological sites, and in the few that we've had the ability to excavate, the increase in material density of materials at those sites at about 4,000, 5,000 years ago. That is consistent with the change of use. Certainly more use, heavier use.
Is there a gap between
No.
the first human use and then when the ice dissipated finally on the mountain?
There is no sign of any interruption in the use pattern that we can tell from the archaeology. It's been more or less continuous. Is that what you're going with that?
You had a lot of ice here and eventually it started dissipating,
Yeah.
and then so opened up areas that had been under ice. When did humans start using that?
That's what I'm talking about. That's be 9,600 years ago, 10,000 years ago. That the ice had melted up the mountain far enough and vegetative patterns had reestablished themselves far enough that I should have been clearer about that. But when I say vegetative patterns of mountain, I'm not talking about the foothills. I'm talking about elevation like 4,000 feet and above. They were established by about 12,000 to 11,000 years ago. Human use started to be recognizable so far anyway at about 10,000 years ago. And then from that time of 10,000 years to the present, there's no indication in the archaeological record there's any interruption of use for any extensive period of time. And finally, the apocalypse, 1750, 1770, when use becomes spotty and limited, and the myth of the indigenous free mountain begins. And then sort of finally, sort of inferences that they're not quite so firm, but things are looking this way, first of all, that people sought out montane subalpine habitats because they were good places to go. They may have been pretty, they may have been religiously motivated, but all of that aside, most material requisites of life that primarily drive human use of an area, which I'm suggesting they do, that people sought out montane subalpine habitats and alpine because they were seasonally productive places to hunt and gather ungulates and other early sterile stage species. They came out here because it was good place to go, and they did it early. And lower elevation forested settings are also used, more difficult to recognize in archaeological signature, but present for medicinals and other material resources available there. In the process, they created a variety of site types reflecting varying functions on the mountain, which you've gone through, beginning about 10,000 years ago with continuous seasonal use through time. Mount Rainier. Secondly, hunter-gatherer strategies changed through time as well. First by small, very mobile forager groups, then later as task-specific collectors linked to permanent fishing villages about 3,500 to 4,500 years ago. And then finally the modern tribal in the 1800s, which came up earlier talk. But limited gathering continues on open land, mostly administered by the National Park Service and the Forest Service. And that's all I got to say. Hour and a half talk took us from 9 o'clock till 11:15. I'm happy. I hope it was intelligible. I hope I didn't say, I got my times mixed up throughout.
With the construction work that's going on at Ohana-Kosh and SR 123, there's some amount of excavation. What role would you expect archaeology would be playing in identifying any accidental discoveries and accidents?
Well, yeah, we work with the maintenance division. It started actively before my time and bloomed before that. When we find out what projects are, when projects are scheduled, we meet with project scheduling, find out when they're scheduled for, and we do site survey for surface survey first. They're doing that at Ohana-Kosh now, and then subsurface survey using that constant volume sampling technique that I've talked using with post hole diggers. especially incurved handle post-hole diggers, has been something we've done right from the beginning, because the only way here you can get down deep enough to really get a good look. So that has to take advance first. If you don't find anything, then go after it. But then usually have an observer on hand during the process in case you have an inadvertent discovery. And if you work with the maintenance crews, it works great, because they're not afraid to turn stuff in. Because we work with them. They're not
So
afraid.
you're part of the normal, your schedule?
Yes, yes. And Ben got his start in the park because I was by myself, and I was really interested in the research issues of the park. And I had that and tribal relations, and we needed somebody to deal with what's called compliance archaeology. Bodies stay compliant with the National Environmental Policy Act, which requires this kind of testing. So Ben became the compliance archaeologist a long time ago. He's really good, got really good at it, that kind of stuff.
Just like a simple, but how do they, right now, I haven't been down to Ohana for a long time, but the campground, when it was active last year, let's say, how is it protected, that site protected?
Well, dirt. It's
Okay,
covered
so they
over.
how do they?
We refilled all those.
They
50
refilled
yeah.
and it's like, okay. got
There's
it.
very little looting goes on at that
Sure.
place because there's nothing visible on the
Yeah,
surface.
okay.
That's one of the
Makes
mysteries
sense.
that we're working with right now is why is the archaeological record at Ohanapecosh all underground? Why did nothing get found on the surface before? And the only way that I'm sort of coming up with right now is we had geologically it's called unconformity. That means where time has been removed from the geological record. And so there has to be a heavy erosive flood sometime before the recent volcano, say about 1,000, 2,000 years ago, that removed that top sediment layer, and then more normal quiescent flooding happens again, builds the sediment level back up to where the modern surface is. So you've got an artifact-free surface overlying and hiding, in some ways fortunately, a much more robust archaeological presence underneath. It's a cool place. I sort of reorganized my thinking too, because I had really focused on the subalpine focus on the park, which I've emphasized still. But it's oh no, first of all, people can't just fly up here. We've got to get there somehow, and it takes more than a day to get up here, so they're going to have camp spots. And plus, hot springs kind of changes the matrix. That's a resource that people have sought out for a very long time.
But your research kind of shows that since the mountain has been used since basically the indigenous people have been here, right? I mean, and because I can't remember what was the name of the mummy that they found that was returned to one of the tribes down in Oregon. It was like 14,000 years old. Within
could
the
be.
last. Huh?
Kennewick.
Yeah, Kennewick Man.
Yeah.
Yeah.
Yeah, well, they're kind of Washington. I've seen the reburial spot, in fact. It's
But I mean, it's mutually supportive, right?
should be, yeah.
Well, it appears to be. I mean, yeah.
Which is mutually supportive. What?
The sites that they have found down in the
Yes.
flatlands, assuming that the people came up from the.
Right. No, that part I am using a larger archaeological record. And when I put those early dates on there at 15,000, there's one site in Hell's Canyon, very smart archaeologist working it too from Oregon State. He claims dates to about 16,500. Too early. It's just a little too early. I don't know. That's still an anomaly. And there are several others in Oregon that are claiming dates to about 15, which could be. And there's a White Sand site, which some archaeologists are still claiming 21,000. Other than that, in North America, they're 15,000 and less. It's pretty definitive, actually, almost, not quite. Anything else? Well, thank you. You've been fun. You've been a lot of fun. And